living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. The world where we glide, from the peaks to the seas, exploring with ease. Mapping the future's bright, our bond ignites the night. Collaborate, innovate, together we elevate. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. The heart of the tech beehive. Liquid galaxy, we see an old technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Tech beehive. In the heart of the tech beehive. In the heart of the tech beehive. Screens, living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. The streetways are wide, to the world where we glide. From the peaks to the seas, exploring with ease. Mapping the future's bright, our bond ignites the night. Collaborate, innovate, together we elevate. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see an old technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Tech beehive. In the heart of the tech beehive. In the heart of the tech beehive. heart of the galaxy where the stars align. We gather as a community with a vision so divine. Panoramic views, a world we can explore. With Liquid Galaxy, we open up the door. Echoes of the galaxy in every beat we play. Innovation shining bright, lighting up our way. Together we create, with passion and with pride. In the Liquid Galaxy, our dreams and worlds collide. Gaia spatial wonders unfolding at our feet. A journey through the cosmos, a visual retreat. From mountains to the oceans, we see it all so clear. With every map and image, the universe draws near. Echoes of the galaxy in every beat we play. Innovation shining bright, lighting up our way. Together we create, with passion and with pride. In the Liquid Galaxy, our dreams and worlds collide.
Hello. This video is for the submission of Build with AI for Marketing Climate Dashboard. About me, I am currently a second year undergraduate student at National Institute of Technology, Rourkela, and my interests include artificial intelligence, robotics, and open source development. So my name of my project is Martian Climate Dashboard, and this is one of the visualization that would be created by my project if selected. On the center, there would be, you could see a visualization of the wind component on Mars. On the right-hand side, there is summary of the visualization that is generated by AI, along with the logos that are present on the left-hand side. The goal of my project is to create visually engaging and interactive AML or visualization about Martian climate database or Martian climate that could be both real-time and historical. Mars Climate Database is a database that is created by various European institutes, and it is also supported by European Space Agency. It gives data about various parameters on Mars, for example, temperature, density, climate, wind component, snow, etc. My project would include a Flutter app, which would fetch the data from the database, process it, and then create a PML or visualization uh, for the uh, for the different parameters. My, my app would also include an AI bot, which could be used to create doubts or queries about the visualization, and it would also be used to generate summaries about the visualization as shown in the previous slide. Uh, the API that I'd be using is Gemini. So I will be using this website, that is Google AI Studio. It provides various models, for example, Gemini 2.0 Flash, Gemini 2.0 Flashlight, Flash Thinking. There are many previous models, for example, Gemini 1.5, Gemini 2.5 are also present. The one that I'll be using in my project is Gemini 2.0 Flash. Uh, I'll be using this model because of its capabilities to understand as well as generate images, which is required for my project. These API could be used by by obtaining an API key, which could be obtained using the same website. The constraints of this API is that it only supports 15 requests per minute, a million tokens per minute, and these are the maximum numbers, and 1500 responses per day maximum. These limits are generally not reached when working on for a small app or small project. So I don't, and these limits are very generous. Uh, so the API would not cost anything for the whole project. The database outputs an image like this as shown on the image, as shown on the screen, as well as some SKY data that could be used to generate the TML. The image could be used for the AI model to provide it with context or to give more reference to the AI bot. So this is, for example, if I was to ask why there is a blue color patch in between uh, all these different colors, if the image was not present, the chatbot would not be able to answer it correctly. If I give this the image, so it would have more context and it will be able to answer it more accurately. The prompt for the model should be something. This is the prompt for my this app that I submitted for Build with AI contest. So in this example, I have divided into three sections. First, I give the role to an model. For example, I gave this role of assistant in an app, that visualization, location, and flight path. The second thing that I gave it is the output that is supposed to be there. I usually prefer to output it in JSON format, since it is the most easy format to be passed by the uh, app or Dart. The third section is the important points that needs to be taken care of before returning the response, since uh, since since some garbage information could not be should not be returned in the response. So this makes sure the output is up to the mark. In the end, there's this text user prompt. So what will happen is that when the user asks some query, the query will get appended to this prompt, and then it will be asked to the AI chatbot, and the chatbot will then return the response in the form of a JSON. That JSON will then be passed to a map or a list, and then that list would be used for generating various KMLs like place mark and balloons for generating for showing the summary of the visualization. So these are some examples that could be understood from this. So what is the largest? So first example is the what is the largest moon on Mars? So this is the prompt. The user asked this to the chatbot. So the chatbot returned this location or coordinate of the largest volcano. It also returns some information which is then displayed on the balloon on the right hand side. So this all was present on a JSON format, and it was passed in the form of passed into a map, and then these balloon and this KML was generated. Similarly, on the right hand side, show the south pole of Mars. In this also, the coordinate of the south pole was given by the AI, and also the description of the south pole was given. Other than the coordinates, that is the longitude and latitude, the range, the heading, and the tilt was also given by the AI to make it more aesthetic or more interactive. For example, here the tilt is much more than this because it is present on the South Pole. What makes my project special is that while the database only outputs a static image, it is not interactive at all. So to make it interactive, my project converts it into a visualization that could be interacted by the user by using KML. My project also incorporates the use of AI by providing solutions to the user's query or question while understanding the visualization. Uh, my project would also be used for understanding the Mars climate by anyone from a researcher to a student who is curious about the Mars climate. So this was all from my side. Thank you for giving me chance to present my proposal.
Hello everyone. Myself Jayvardhan Shukla, and this video is basically my submission to the Liquid Galaxy AI Developer Quiz Challenge, whereby I have created this temporal explorer application. So in this video, I would be discussing about how I created this application, my code base, my code structure, and what this application is capable of, what APIs it is using, and finally giving a brief demonstration of this application using the Liquid Galaxy rigs, which I have already installed and configured in my computer. So here's the demonstration of the same. So firstly, I would start by introducing the to my code base. So basically, I have utilized the following packages for creating this application. These are first of all the Google Generative AI. This is a very important package, and it basically helps us to connect to a lot of Gamma and Gemini models. Then next is Flutter TTS. Flutter TTS helps us to do the voiceover thing, which is also present here. So if we speak anything, this application would basically get our speech and would display it to the basically get our speech and would take it as an input, give it as an input to the API to fetch the results. Next are some providers and path providers which are useful for basically sending the KML. The next is no important package is the Dart SSH2. This one is utilized for sending the SSH commands to Liquid Galaxy. Also, our KML, which would be generated by the Google Gemini itself. So now I would go on with my files one by one. So first file is basically my main file. This basically introduces my application. So my application name is Temporal Explorer. I have used systematic font scheme and Material 3 layout in my application. So as we can see, there are two important routes in my application: the settings screen and the about screen, which are part of the main screen itself. So the home screen would be the main screen, and there would be two alternative screens. So first of all, let us visit the alternative screens one by one. So this here is the about screen. The about screen is generally gives the description of the project, what technologies is it using, and the by whom it is created. So the next is the settings screen. Setting screen provides an option for the user to enter their own Gemini API. Currently, initially, my hard-coded API would be shown here. So users can also use the application by using my API. If they want, they can also use their own API and can save the settings. So next time when the user does it, their own API would be shown here and would be utilized for fetching the results from the Gemini API. Next is the basic Liquid Galaxy connection. We can see that the connection is already established to the Liquid Galaxy, which is open right here. So we can choose to disconnect and then connect again to the Liquid Galaxy. The application would then be connected, and then this layout would be there. So I would first of all go to the main screen. So in the main screen, we are first of all using the uh, KML visualization. We have to first of all give a particular query to the user. So for instance, if I give a query like give me a tour of five most important cities in India, while also presenting some important information about them, and I click on the explore button, this would fetch the important results in the form of the KML. So this is basically my home screen. Here is the code for the same. So we can see that there are a couple of buttons here. See, this is the sending to LG button, which would only show up after the response is generated. So if I click on this button, the whole KML file would be there, and clicking on this button would basically send this command to the Liquid Galaxy. So this is how this file is. Now next, what I would do is that, So this is how this file is. Now next what I would do is that I would take you to the app state. The app state file basically is used for connecting to
Your
the Liquid
KML
Galaxy via
file
all
is
the
ready.
SSH. So we have defined our LG settings. We have defined our SSH client. We have used all the getters right here. Apart from that, so first of all, we are trying to load the settings which are there in the user, and then we would get the API key from the shared preferences if the settings are already saved. The next thing is that we have to set the API key if the user gives it in the first time. So these are the functions which would be executed then. These bunch of functions are used for setting the rigs, number of rigs, the API key, the uh, username, password, the port, and so on and so forth. So above it is basically the connect to LG button. We can see if the IP address is empty, then the connect to LG would be failed. Otherwise, we have to first disconnect if the connection is already established. Then we have to create a new connection. So we can see there is a socket connection right here, ssh socket dot connect. We are giving the port and IP address, and we are giving a timeout duration of 50 seconds. So within the 15 seconds, if the connection is done, then only the connection is established. Otherwise, this would be failed. So the next function is to disconnect from the LG, which basically used for disconnecting from the Liquid Galaxy system. We are just calling the close function in order to close the connection. Uh, then this is the execute command, which is a helper method to execute commands. We are not basically this is for giving a string based command in the form of KML file. And similarly there are other functions also in the same way, like for instance if we can see send KML to LG. So this takes string KML content and parses it, and also sends basically this to the Liquid Galaxy system. It creates a new directory in the SSH, and then gives a file name, gives a timestamp, and then uses the SSH clients dot sftp in order to open this file. So this is the whole structure of these. This is how we set up our tour. All the basic functions are written inside the app state.dart file. Now there are a bunch of test functions also which are not needed, but where they're useful for doing a development purpose. So this function is used for cleaning the KML. So basically, we clean the KML in order to remove all the redundant balloons and everything. The below function is for relaunching the LG, which successfully launches the whole setup. Then finally, there is this system prompt. So I would tell about the system prompt later, like what it is, why it is useful. But it is something which is very necessary in order to give provide the relevant info to the Gemini API, so it only fetches the requisite output. So the next important file is Gemini service. So in the Gemini service, what we are doing is first of all setting the API key, which is hard coded to my own API key for default. The user can choose to write basically give their own API key, so the shared preference would save that and would not use this one. So this is basically dependent on the user. Secondly, we have to set up a generative model. So if we see here, the generative AI Dart file is there. So this is the only package which is used. Uh, we can see that I am defining the model inside the Gemini KML service method, which is called in the init state. So we can see that the model used is Gemini 1.5 Pro, and the API key is given. So this one model is utilized, which fetches all the requisite result. So we can see that the older command kml is fetched to us right here. The user can choose to see this, the user can choose to not to see this by turning on and off this particular tab right here. If the user clicks on the visualize this Liquid Galaxy, then this kml would be sent to the Liquid Galaxy and would be shown to them. So The next thing is generate content. Basically, it generates the content based on the given string. The string is provided right here in this box, so we can take this from there. So finally, there's the system prompt. System prompt is basically something in order to fine tune this model. We can provide a system prompt so that the Gemini only fetches the requisite results and behaves in a certain way. So we can see that I am providing this prompt that you are a KML generator to the Google Earth and the Liquid Galaxy, and only result the output in the KML. The primary result is to produce a rich, immersive, visually stunning tools. So since the application is primarily focused on tools, so that is why the tool factor is there. Uh, Next thing is I have provided a certain guidelines on how the tool should be there, like in order to provide a stunning visual experience to the user, the tool should stop and each place marks, and so on and so forth. There should be certain styling blocks in the top, the structure of the KML document, and how much duration of the fly to should be there. The fly to mode should be like what, and where is the look at and camera position while defining the tool. Everything, each and every other instruction is provided in the system prompt itself. So the system prompt is first read by the API when it initially gets set up, and then the requisite prompts are executed one by one. So we can see that I have provided 10 prompts, and then finally it basically sends like this. So full prompt is basically the prompt provided, system prompt plus the user query. So system prompt is given to the API each time the query is run. So then finally we do the block formatting of the code, and then returns the code return we basically return the KML generated so that it can be used to visualize on the Liquid Galaxy. So these are the main files. Other important files are the voice recognition files, which basically use the TTS in order to do the speech recognition setup. So they are the whole speech recognition setup which are done for the Liquid Galaxy. So we can see the whole things. So these are the basically the codes for the same. These are for the TTS service. We can set up the language, speech rate, volume, pitch, and we can two basic functions, speak and stop, which are called on whenever that basically till the time the user sends their input, these functions would be called. So this is the basic setup of my code. Here is the application for the same. I have attached all these screenshots in my documentation, so one can view the screenshots from there itself. And thank you so much.
Hello everyone, my name is Dev and today I am here to present my app functionality. What is my app functionality and what I have made for this build like with AI contents. So my app is basically focusing on what can save time on error solving. So I have been not scrapping but taking the values from the Liquid Galaxy website and the one more website. So it will fetch data from that and provide us answer. This all is done by the AI Gemini API. So let's start and see what and how it's look. So let's go. So this is my app over here. So I have a Liquid Galaxy boot. What I have told you to you about in the starting, that how can we stop the timing of the error. So if I say anything that install rig, it will process the data from the website and give us a perfect answer that we can follow with a customer manner. You can see that it says how to install a rig and all the things. what we need is a type Linux or Google or Pro, Chromium Chrome, and more specific files of Liquid Galaxy. And another thing I've implemented is mini quiz. This is based on, as well as on the Liquid Galaxy. So if you add any topic like algae, so on your topic it will scan the website and provide you a quiz related to that. So it is more helpful to explore the community with the help of the game. Generate the quiz. It will generate the quiz. What is a primary purpose of the Liquid Galaxy? Yeah, next. How commonly utilize any answer you can click, and if the answer will be wrong, it will be shown the true answer as well. So I can give, yeah, next. So your and the score will be shown on the last option, and you can create and restart the quiz as well. If you will create, you can enter the topic again, and you can make QR code from the app itself. I'm just adding 2.323 input to showcase anything, not adding full. It will generate a QR code, and when which data it has been generated, it will be shown over here. So let's start scanning it. So yeah, I should open my QR code. So you can see that here is my QR code. So now let's scan it. It automatically detect and connect it. After connected, it will show connected successfully. And if you pressing OK, it will be providing you to last screen what to visit. And this bot can generate a simple KML. Up till now, we can add and generate more complex KML in the balloon. So let's open my Liquid Galaxy. Yeah, so here is the Liquid Galaxy. So let's first clean the pop-up that has been running. So here is the LG task is the balloon goes. Let's generate a KML on the Lleida. It will generate KML, and in at the bottom you can see the KML on LG rig. So if you press this, it will add a pop-up over here. You can see it. It added that normal balloon. Let's, yeah, over here a point, added a place mark and a balloon dynamically. So this is a basic app I built on Liquid Galaxy for Liquid Galaxy built with AI competition. So this was about the app. Thank you for watching it.